start with number one. This one, all of you should be able to do in your sleep. The domain in the range of inverse tangent. What's the domain? Oh. Yes. And then the range is, why are they not brackets? Yes. Asymptotes. So that one was easy. That would be like an R2. The second one, to find the exact value of sine inverse. Yes.
You got those mixed up with the right. Can we do 0.5?
Probably not, because then you would be giving the domain in the range of just sine, or of just tangent.
Okay.
But you'll know, you'll fix it for the test. So at least you've seen what the mistake you'd make. So sine inverse of pi, or root 3 over 2. So this is just stuff you've been all doing for a while. So you make your triangle, and sine is opposite over hypotenuse, so root 3 over 2, and this is 1. So this angle is equal to what? 60 degrees, or if you say pi over 3, that would also be correct.
Yeah, what if you 3 is double points? Right?
No extra credit. No. Yeah, if the
Yeah, what if you, I also put down 1.1.
and that is a very good point, and we were going to get to it later, but let's talk about it now. So you're saying you could have one here. You could find this thing over here, right?
Well, I mean, I don't know. It's obviously not.
The reason that, so if we did it over here, here's our angle. Opposite is root 3 over 2, and that's -1. So yes, it would still come out the same thing. But who can tell her why this one you cannot use? Why it wouldn't be valid? Yeah, yes, Wilson. Or who's Wilson?
It's not in the range.
Yes, this one's not in the range. Remember, the range for sine is sine inverse is negative pi over 2, pi over 2. So your answers could only be from this area.
Oh, yeah, you showed us that picture of it.
Yes. Yeah. So, what?
So then do like the range for the codes on that, just like.
Yes. So then this, okay, I'll do it for you. So the blue is the range for two things. What? Sine and what? Tangent. The red is cosine. It's from 0 to pi. So be careful with that on the test, because that would be a stinky one to get wrong, because these would both be R2s. 1, 2, and 3 would be R2s. Okay, 4. Did I skip 3? Well, then 3. Perfect. So, arc cosine of negative root 3 over 2. So, we're working with cosine. Draw our unit circle. And that's off, but where is cosine negative? So, is it negative here? So we're not working there. What about here? Can cosine be negative there? No. So it's these two. Now, knowing what we know about ranges, what quadrant are we going to actually focus on? 2. Because our answer could never be here because it doesn't fit our range for our arc cosine. So we draw our triangle. Here's my angle. And it's adjacent over hypotenuse. And so what is that angle measure? Yep, so that's 30 degrees. So what is this angle measure? 150 degrees. Yes. because you said for this, this one then? So then that would be, I would give yourself half on this, but on the test, you have to know that that's not within our range. So if you give an answer outside of the range that it's undefined, it really wouldn't work. But yes, so just write that down on your sheet. Look for ranges. Yes? That's fine too. So that's what, 5 pi? That's fine too. 6, not 60. Okay, now on to an R3 type question. Cosine of arc cosine negative 1/2. So, this is something I want to talk about, and it's been confusing for the other hours. Remember when we said we could go through and cross those out and just say that that's our answer? From now on, you have to go through and solve it. Because sometimes you won't be able to do that, and if you do that, you'll get the wrong answer, and then you'll be really upset because you did that. So let's solve this. Let's go through and solve it. Where is cosine negative? We just talked about it. It's right here, right? So negative 1/2. So here's our angle. And then opposite is, adjacent, negative 1, 2, root 3. So what's the measure of that angle? 60 degrees. But really, what is this measure? So it's 180 minus 60, so 120 degrees. So cosine of 120 degrees is what we're looking for. Now what's cosine of this one? Negative 1/2. So there's a time where you could go through and cross off, but I would just recommend going through and solving them so you know for sure. Because there are some instances where if you cross them off, you won't the answer wouldn't be right. So it's worth going through and solving them. I want to just throw one in here quickly. What if I did cosine arc cosine of 2? So this is an instance where you can look at this number, and this is our domain value. That's what we're inputting. What is our domain for arc cosine? Negative 1 to 1. So right away, you know that this is not possible, so you could say undefined. And I guess for this one, you could have done the same thing. You could have said, oh, is negative 1/2 in our domain, and is it? So then you could have actually went through and crossed out. But sometimes going through and solving it would just be the best, so then you know for sure that's the answer. Does that make sense? Okay, the next one. So that was 4, right? So now we have sine inverse sine of pi. We're not going to go through and cancel out. This is one where you should go through and solve it. Okay. So, here's pi. And what's the question? Do you have a question? No? Okay. So this point is negative 1, 0, right? So sine at pi is what? 0. So now our new problem becomes sine inverse of 0. Now sine inverse is 0 at 2 spots on the graph. Here and where else? The other side, right? So now which one's the answer? There's only one. And how do I know it's my answer? The one on the right. Great. And so my answer would be 0. Why would my answer not be 180 degrees, or pi? Why? Yeah, so if we said this was equal to pi, that's wrong, because pi is not in our range for sine inverse. It has to be here, just if you remember that. And that point is, which is 0. 0 radians. Yeah. Yeah. Okay. And then the last one. Who thinks they got this last one right?
I think so.
Okay. So this one is cosine arc sine of 4 over 5. So we have our circle, and we're just going to draw the triangle right in there. Here's my angle. Sine is opposite over hypotenuse. Now, how do I know this side length?
3, 4, 5.
Yep, it's a 3, 4, 5 triangle. So this problem, we can't use our reference triangles to solve this one. So what we can actually do is we can actually leave it in side lengths. So arc sine of 4/5, we can say cosine of some theta. What is cosine of that angle? 3 over 5. So your answer for this, you don't even need to know that angle measure. It's kind of irrelevant. You can use the same triangle and you can know that the sides are 3 over 5. Yes. Yeah. Yeah. That would be the same thing. Yes. Yeah.
Would it also be plus or minus since it is cosine that works and on both sides? No, it's the ultimate sign.
Yeah. So, yep. So it's just going to be right here. Because sine, yes, because sine can only be in that one quadrant.
Arc sine.
Arc sine, yes. Thank you. Yes.
When do you have to check for something to be in the domain versus the range?
So if it's the range, you're looking at the angles. So the angle, so if you're going to put an angle answer, you have to make sure that it's in that range. Otherwise, usually if arc sine or arc cosine or arc tan, if it's inside, that means you can look at the domain. So like for this one, what is my domain for arc sine? Negative 1 to 1. Does this fall within there? Yep, so we know that we can go through and solve it. Yes.
Number 6, what magnitude of a question is that?
R3.
Oh, yeah.
I did think that one's easy compared to the other ones. They can get kind of confusing. So what we're going to do is we're going to just do a few more practice problems. Or do you want to get started on your homework? You feel ready for homework?
Yeah.
Who got 6 on the quiz? Who got 5? Okay, who got 4? Okay, so let's be done. I'll hand out the homework, but I want everyone to start the homework, and I want you to ask any questions that you have, okay?